Thank you, Max, for that kind introduction. And we're very excited to see so many of you here signed in tonight. Um, my name is Richard from Adiona, and we're very excited to be sharing our topic tonight, which is called Using AI to Reinvent Service Logistics and Improve Customer Experience and Customer Service. So I'm going to share my screen here. And the name Adiona is the Roman goddess of the return journey, and she was particularly assigned to looking after the young. We at Adiona believe that logistics and transport efficiency is critical to having a sustainable urban future. We provide an advanced optimization AI platform to logistics and mobile workforce companies that is backed by decades of operational research and uses the best in modern cloud computing to integrate into any legacy system. Now, by incorporating historical data and new AI-driven analysis and planning techniques, product replenishment and routine service models can be significantly improved while still keeping their core structure, resulting in double-digit efficiency and customer satisfaction increases with minimal disruption to the operational model. With 3 exciting real mini case studies in facilities management, construction materials, and vending machine replenishment, you will learn how almost any business can implement high return on investment projects with minimal spend in a matter of weeks. Now, to help me focus the talk, I'd love for you to vote for the topic that you're most interested in out of those 3 in the comments. That's facilities management, construction materials, or vending machine replenishment. Just comment with the one that you're most interested in. Now, one of the most frequent questions that we get at Adiona is from logistics leaders about what is AI and what is machine learning in the context of logistics and supply chain, and why is AI disrupting the industry, and what do I need to know about it, and what is this technology going to do for us? So this talk is going to look through the lens specifically for the service logistics industry. And of course, we can't not talk about COVID-19 right now as well. So I highly encourage you to send questions in the comments, and I will try and answer them as quickly as possible. And just so you know, everyone watching this is entitled to a free 2-hour consultation where we at Adiona will talk about your specific challenges with you and your opportunities. So feel free to email us or call or send a contact form via our website to get in touch. So this talk isn't about AI fundamentals, but if that's of interest to you, head to our blog and you can find content on that. What you do need to know for now is that machine learning is a fundamental component of artificial intelligence and actually makes up most of the concepts that we talk about currently in artificial intelligence, or what we call AI. And you also need to know that AI isn't necessarily for everything. It cannot solve all of your problems, even though it is an incredibly useful tool. Some awesome projects can be done with traditional data projects and traditional data methods and don't require AI or ML at all. And some projects benefit from both, a blend of traditional types of data analysis techniques and incorporation of newer machine learning models. So it's important to use these types of decision trees that you see on the screen now to understand and inform which way to go with your project or with your goals. So in logistics, there are 2 fundamental types of machine learning projects. Those are projects for cost reduction and projects for insight generation. So you can use these decision trees to quickly assess whether a project you have in mind is feasible or worthwhile. And we don't have time to run through them in detail, but feel free to email me for a copy of this deck, and you can get a copy of these decision trees as well. Now, of course, I promised some case studies. So this first one is in facilities management, and it's about a facilities management company that is doing mainly washroom services for offices. Now, they've been around for a long time, and they already had a significant customer base nationwide, but they decided to start experimenting with Google Ads and digital ad campaigns. The digital ad campaign turned out to be a huge success, and they started converting a lot of customers from the competition. And suddenly they were growing at 5% month on month. Now, with 10,000 customers already, that's 25 new customers every day spread across just a few dozen contractor vans. They had been managing their routes manually in Excel and had even started experimenting with things like Google Earth and other freeware, but those weren't exactly solving their problems and making their daily lives any easier. And I wonder if any of that sounds familiar to you in the audience. Please let me know in the comments if that sounds familiar. Some of the particular challenges that they were facing were lots of manual back office time to handle customer churn, balancing customers across contractors and assigning them to the best contractors and the best routes, handling contractor churn, that's bringing new contractors in and replacing ones that have left, and including the recruitment process of getting new contractors in, and using their data to plan for future resource needs. For example, when and where should they be thinking about adding and recruiting new contractors? One of the biggest problems in finding software to help them do all of this is that their service is planned around routine visit frequency on a weekly, fortnightly, and monthly basis. And they could not find any tools that were able to handle that type of complexity, along with all of the other constraints they had, for a reasonable cost. So the first thing to do is visualize the data. And here you can see an example from Melbourne here in Australia. And on the left, you see that the visit frequency is visualized by this flag system. This is something we've developed at Adiona. The color tells you the day of the week, and the number of flags on the pole tell you the frequency. So for instance, the flags at the right side of the screen underneath where the comedy theater says, that's 2 red flags on one pole in the first and third position. And that tells you that this contractor is going to visit the customer at this office twice a month on Monday. So that's Monday fortnightly. And then if you look at closer to the center of the screen, there's a purple flagpole with 4 flags. So that customer is going to be visited every week on Friday. Hopefully that makes sense. Now you can see from their fancy Excel work, if you look at the clustering and the grouping of these for specific days of the week, they've done a great job creating manual routes. But the complexity of balancing these routes, especially in the face of multiple contractors and new customers churning, the specific workday for each contractor meant that there were some inefficient visits. So you can see here, even on a Monday, for instance, in the red cluster, they're mainly concentrated in the south side of Melbourne, but every Monday there are exceptions where they have to go to across town. They have to go far north, far east, far west. And that adds a huge amount of inefficiency to their routes, as opposed to being able to stay in one general area. And all of this was getting worse and worse, as we mentioned, with the 5% month-on-month growth. So have a look at what our FlexOps API process does. Our machine learning and AI has a special genetic clustering algorithm that solves for all of these complexities automatically. It takes the customer locations, the visit frequency, the timing requirements, the working hours for each contractor, and any other custom constraints needed for their specific business, and iterates through millions of options to create the perfect schedule. So for this individual contractor, this new route was generated in seconds. And you can see the clusters on the map are tightly constrained, and there's no crossover where on a given day of the week they have to travel across town. They're staying in one general area of town for any given day of the week. Now, for this contractor, this reduced the average service time by over an hour per day. That's an hour per day they have to manage growth or to do other things. And since the contractors get paid on a per visit model, they're saving over an hour every day and getting paid the same amount. Now, it also reduced the customer complaint rate by over 50%. So the ability of the contractor to now hit all of these jobs consistently and on time doubled that customer service satisfaction rate. And really powerfully, the software automatically adds and balances new customers every day to keep the schedule balanced. So let's see what that looks like on a regional level. This is over 10,000 customers across 15 contractor routes in the Sydney region. So all 15 routes are continually updated and balanced. And that saves 2 full back office employees to manage all that work. And of course, the route optimizer breaks every day into turn-by-turn directions as well if they want. So they're doing something far more powerful than just route optimization. This AI is solving for the minimum number of contractors that it takes to do the work. And this company found that instead of 15 routes for this area, 15 very busy routes, they actually only needed 12 routes to manage all of the work once it was optimized and automated. So that's 3 contractor routes that can either be offloaded, renegotiated, or used to handle further growth in the future. And the reason that this can be done is because of that automation engine being able to optimize the creation of routes automatically and to rebalance everything really, really neatly. So that's where the discussion about COVID-19 becomes really timely. Unfortunately, for this company, much of their commercial business at offices was either suspended or canceled when the lockdowns began. So now that that business is starting to come back, they're using these algorithms to rebalance what's left and also to run hypothetical scenarios to onboard their contractors again. So again, where and when should we be hiring new contractors to come into certain areas to accommodate the growth of the business coming back? Because as you know, it's not as simple as just bringing everything back to the way it was. It'll never quite be the way it was. So now to the next case study, which is construction materials. This company has a number of quarries and concrete manufacturing facilities all over Australia and all over the world. Here in Sydney, they truck the rock and sand from the quarries to the concrete making facilities closer to the city. And it's a large operation with up to 100 trucks doing 700 trips per day. Then they truck the concrete once it's made to the work sites, the construction sites. Now, you remember our decision trees in the beginning. Well, once you've gone through that, one of the other powerful tools that you can use is journey mapping. And that's a type of process mapping whereby we map out the way that the business actually works from a high level. And doing that, you can see an example for this company on the left. You can identify where the choke points are in the existing processes if you don't already know. And sometimes you think you know, but there's some surprises once you actually map out the way the business is working. And you can also use that to identify which steps in the process are most conductive to using machine learning and other types of data techniques. So in this example, we identified that a simple change in the process flow, augmented with a genetic algorithm for truck scheduling, and that algorithm includes things like drive time, waiting costs, and other constraints, could really yield some big results. So we can't show you the details of how it works. You get an overview looking at this slide. But the results are absolutely stunning, and we see that on the right. The average load efficiency has increased by 15%. And because these trucks and this operation is so expensive, the savings are estimated at $7.2 million per year. So it's quite profound. So our final case study is looking at vending machine replenishment. And that's a picture of me in front of a Coca-Cola Amatil vending machine. And Coca-Cola Amatil here in Australia has 14,000 vending machines nationwide and their own fleet of contractors to service them. So they've used other optimization tools in the past, but those optimization tools and automation tools all suffer from a common problem. Traditional optimization platforms are very prescriptive. You have to follow their workflow or the process doesn't really work and the tool doesn't really help you. So the realities of the business don't always match up to the tool, and that causes a problem. And also as the business evolves over time and as things change, those differences can increase and diverge to the point where the tools just do not work anymore. But modern AI is very flexible. And by combining it with modern cloud computing and API connectivity, it's endlessly customizable in the right hands. So once it's integrated and trained and starts to learn how your business works and how your processes actually flow, it can actually start to customize itself, providing increasing benefits as it gets more access to data. In this case, manual planning was creating a huge back office block. Planners and contractors were both under lots of pressure to keep inventory up in the machines in order to boost revenue. But there didn't seem to be any ways to get more efficient with the current tools and the current process. So AI and machine learning are able to look deeper into relationships between different kinds of data that may not necessarily be obvious. In this case, there was a strong correlation between the revenue opportunity, the amount of money that could be made from each machine, the fill level of that machine, and then the proximity of other machines in the area that also had a fill level. So from our process map, we were able to determine 4 distinct opportunities for automation and optimization, which you can see in the brackets here on the left, opt 1, opt 2, 3, and 4. We start with the low-hanging fruit, the easy return on investment, and work our way up in terms of complexity. And by that time, you end with a fully customized but very rapid integration into the existing tool system. So in addition, our AI engine uses machine learning to continually update the best times and routes to visit each location, which becomes very powerful for them. The customization comes with a fully customized dashboard for analysis and management in order to visualize the data. Here you can see the relationships that we mentioned between the machines and their fill level predictions and the clusters of machines around them that might be opportunistically filled while the driver is in the area. All of that gets fed into a custom AI optimization algorithm, resulting in an improved process that adds efficiency. So by training our algorithm to maximize the revenue overall, by optimizing the fill cycle, by optimizing based on those geographic clusters, and by optimizing the maximum inventory that could be put into those machines in different clusters, we were able to let that algorithm drive a 16.5% increase in filled inventory. It also increased the number of inventory units per machine, per fill, by 20.5%. It also reduced the amount of time required for both of those things. Even though they've both been enhanced and improved, it still reduced the time by about 5%. And it reduced the amount of drive time on average per contractor by 22% to accomplish all that. And profoundly, it reduced the amount of back office scheduling required by automating it. And that reduced the back office effort by 90%. So the takeaways here are that there are a number of opportunities that you can create with this technology. There are immediate gains that can be made in reduction of back office workload and big logistics efficiency improvements. But there are follow-on effects from those direct efficiency improvements to things like the satisfaction of your workforce and, very importantly, satisfaction of your customers. And in the current climate, there is a lot to be gained from being able to rapidly adapt and stay ahead of changing customers and conditions. There's no better example of that than the struggles that many postal operators are having right now. And that's one of the areas we are focusing on to help postal operators to get out from under the backlog by automating and predicting and optimizing the way that their operations work. It's never been a more important time to do that. So we really hope that you enjoyed hearing about how these advancements in AI optimization techniques are driving real world efficiency improvements and customer service increases in service logistics. By coupling AI with advances in cloud computing, edge computing, wireless connectivity, GPS, and rich data sets, we have so many new opportunities to improve the sustainability and automation of our operations. And we really hope that you will all start to explore these opportunities with your own businesses. If you'd like a copy of this presentation, just email us or get in touch via the contact form on our website. I'll still be here for a while answering questions in the comments and engaging and having conversations. I also encourage you to find me on LinkedIn. You search for my name, Richard Savoie. You'll find me as the co-founder and CEO of Adiona on LinkedIn. I'd love to engage and continue the conversation with you there, and also learn about what other things you've looked at in AI and machine learning and data techniques that I'd love to learn. So thank you for your time. Thank you again to Max and to the entire team for having us and setting this up for us. And we really appreciate everyone's attendance today and look forward to continuing the journey in the conversation. Thank you. Bye.